Well, here we go then, an explanation on how thunderstorms are formed in the UK. Now, obviously, as I've said before, that forecasting thunderstorms is quite well, it's a very complex thing to forecast in the same way that snow is during winter, because all the ingredients have to be right for thunderstorms to develop. So, a quick little explanation here as to how storms form in the UK. The first picture here is a sideways image of the UK. This is the southwest of the UK, which gives a good explanation as to when we see very localized forms developing, and these usually form in very narrow bands or in just one location in one part of the country. Now this here is showing winds conversion or wind conversion here, where they converge into one from different directions. So with the geographical location of the southwest, this is where we're most likely to see this conversion taking place. So we've got winds coming in from these three or four directions here. The instability in the atmosphere uh, causes the warm air to rise. Obviously, once it cools up at the upper atmosphere, it condenses, and of course, with warm air can hold more moisture. Once that does condense, it just falls from the sky and just produces a copious amount of rain in a short space of time, depending on how much of that is sucked up into the atmosphere at that given time. So that's just one explanation of a storm. These are very localized ones, so not in the sort of scale we saw last night, but we'll come on to that next. So that's a very localized storm formation there. So moving on to our next image here on the next screen I've got for you is the high pressure that we've had over the last sort of week or so. Now this is the obviously the UK is the area of high pressure. The jet stream has buckled up towards the north. This is what we call a ridge in the atmosphere here. Pushes the jet stream north, allows high pressure to influence and develop and become strong over the UK and give us proper summertime weather. Now, while this is happening, of course, the heat is building all the time on the land, so we are building a heat wave at this point, because heat waves do build over several days. So last week the high pressure was up here, and the jet stream was where it should be at summer, right up towards Iceland there and going into Scandinavia. This week the low pressure has taken over, and the jet stream has been forced south again. So we have this kink here in the jet stream, and this is what we call a trough here. Now it's where the winds at high speed come down here, but where we get this kink or trough as it's called, that's where the winds slow down, and this is what creates the instability in the upper atmosphere, a cooling of the upper atmosphere if you like, with low pressure taking over. So the higher pressure has been shunted away, gradually moved away, seeping away, low pressure is taking over, therefore instability is created in the atmosphere as this flow begins to slow down over the southern half of the UK. So moving on to the next image. Now once we've got this situation, we come to this point where the unstable air is over much of England and Wales. So we've still got the hot humid air down towards the southeast. I'll come on to that in a moment as to what influence that will have in this. But with unstable air up here, that's the first part of the ingredient that we do need in the upper atmosphere for thunderstorms or showers to develop. So this is where the hot and humid air plays its part. Now for a few weeks now it's been very hot and humid over northern France and southern France, and with low pressure situated where it was just here, there we go, about there, they're just there. So what we're doing here, because this goes in a anti-clockwise direction, we're drawing in this air from France. So if I go back to that last picture there, we're drawing in winds from the southeast. Hot continental air, humid air being pumped into the UK, along with the instability in the atmosphere, the cool air aloft. So with this combination here of the instability in the atmosphere and also the hot and humid air undercutting it, if you like, because it's at the surface, This combination of heating from the sun, surface heating, humidity, and upper atmosphere cooling, instability, this is a perfect ingredient for thunderstorms to develop and become quite violent as well. They do become potent in this sort of setup. So hot, humid air coming in from the southeast across many parts of central southern England. So the final one then, this basically now we have the hot and humid air combined with the instability of the atmosphere or unstable air aloft. So we've got surface heating, we've got these arrows here that replicate the hot, humid winds that are coming in from the southeast, and of course this allows everything just to go up, and of course when warm air goes up, as we know, it cools, it condenses, but this can go from right from the surface level, 2 meters above if you like, so uh, more or less where we are, then it goes right up into the upper atmosphere, and it goes way up, so it goes as far up as where planes fly. So as you know, when you go on holiday, you generally fly above the clouds. Planes obviously do try to avoid storm clouds if they can, and they do have to take alternative routes to do that because they can't fly higher, so they take an alternative flight path, because these huge cloud formations of thundery activity go way up into the upper atmosphere as far as they can possibly go, and of course whatever goes up must come down. So that's what we call a supercell. When you hear the word supercell, it's a very powerful thunderstorm, and brings thunder, lightning, rain, hail. And the reason we get hailstones in a thunderstorm is because the upper atmosphere is so cold, and obviously this funneling of the warm air moving so far up into the upper atmosphere and cooling, it gets so cold it falls as hailstones, and it cools the air as it does as well. So we call evaporant cooling, very much what we see during winter time. So that's what causes thunderstorms to develop. You do get dry thunderstorms, so you do just get electric storms. A little bit more detail to explain that, so perhaps a separate video for that one. But certainly, this is probably a simplest version of, well, simplest way to explain how a thunderstorm works. You do need humidity in the atmosphere. You do need several days of heat wave to build up, so the atmosphere can be full of energy when these things do occur. So surface warming, humid hot air coming in from the continent, low pressure aloft in the upper atmosphere that causes the warm air to condense and produces copious amounts of rainfall in a short space of time. Obviously, if you've got any further questions, feed them back to me on Facebook, either inbox me or post on my wall. But thanks for watching.